If you're watching this video, it's because you were absent on the day of the lab. So make sure that you've clicked this link to the simulation, and I'm going to show you how to set up the sim and how to take measurements. So first, we're going to go to the simulation. We'll set up by selecting oscillate, no end, no damping, and the ruler. We'll hit pause, and we're not going to adjust any other setting. So in the simulation, it looks like this. We're going to set this to oscillate. I'm just going to hit pause for now. No end. So now it's this big open window. We're going to change the damping to none. Right now, the waves are damped, which means that the amplitude decreases over time. We want to make sure that we have nice harmonic oscillations, so I put no damping. Going back to the simulation, look at the ruler. How many increments are labeled between each centimeter? So let me make sure I put this ruler in here. Okay, between each centimeter, for example, to get from 1 centimeter to 2, I have to count 5 spaces. 1, 2, 3, 4, 5 to go in between. So there are 5 spaces. 5 is that answer. What is the value of each increment on the ruler? Well, if between every centimeter there are 5 spaces, then that is 0.20 centimeters per space. So, or for each increment. So the answer here, 0.20 centimeters. We're going to choose one variation of frequency. Do not choose a frequency value that produces less than a whole wavelength visible on the screen. Visible on the screen. Hit the play button and allow the string to oscillate. Hit pause. Move the 0 centimeter line to the crest or equilibrium point of any wave on the screen. Measure the wavelength 3 times, repeat for 5 different frequency values. Alright, so to start, what do I mean by choose a wavelength that at least produces one whole wavelength visible on the screen? If I change the frequency to 0 hertz, you can see, okay, it doesn't oscillate. There's no oscillations here. If I increase the frequency slowly, you can see that you get an oscillation, but you cannot see the whole wavelength. You only see part of the wavelength on the screen. So we have to go with at least a minimum value for frequency that would allow us to see an entire wavelength. So this is pretty good. I couldn't see a whole wavelength potentially, but I'm just going to go ahead and increase to 1 hertz. Okay, for sure I can see one whole wavelength. So what I'll do is I hit pause. And now I measure with the ruler, with this horizontal ruler, the value for one wavelength. Remember, a wave is, we follow the 3-2 rule. So a full wavelength needs to go from a crest to another crest, or from an equilibrium position where the amplitude is 0 to another equilibrium position. I can't encompass 3 whole equilibrium positions, but I can encompass, I can see 3 maximum displacement values, or 2 troughs and a crest. So I will measure here. With the ruler, I'll put the 0 centimeter line on this trough, and I will estimate to 2 decimal places of precision the wavelength, following the 3-2 rule. 3 bumps, 2 equilibrium points, that's a wavelength. So from this screen to this screen, this looks around 6.23. You have to estimate to 2 decimal places. So I'm going to estimate maybe this is 6.23, 6.25. That's why we're taking trials. So at a frequency of 1 hertz, I'm going to skip over the period part for now. This is 1.00. Remember, units only at the top. For trial 1, 6.23. That's my first trial. To get the second trial, I hit play again. I let it oscillate. I hit pause. I remeasure. Remeasuring, still pretty much in the same spot, but maybe 6.25. I need 3 estimates. 6.25 and trial 3. Again, come back, hit play, let it oscillate. Now I can go from a crest to a crest. Now the crest is slightly over here, so that's the 0. And maybe this is around 6 point, almost 3. It is an estimate, and I'm glad I'm taking trials. 6.3. You can see this isn't perfect, but estimate this is around 6.30 centimeters. Okay, hold off on taking average wavelength and the period because I will have another video that shows you how Excel can do this very quickly. Thanks for watching and study well.